All right, so we're going to do the last part of this FRQ, the part C. A random sample of 20 children born in the region will be selected. What is the probability that the sample will have at least 3 children who are left-handed? So this is a binomial question. All right, so I'm actually going to take some more space for that. And I want to just kind of make sure we understand why it's binomial. That's not part of this problem, but just broadly speaking. And I want to make sure that we talk about how to do it, how to think about it, how to visualize it, and fundamentally how to write it down so it looks good and you get credit for it. So that's sort of the ultimate goal. But let's start at the beginning. So heads up, guys. We are leaving the multiple birthing behind, right? So we're looking only at the left-handedness. So heads up, this thing we got in part A, that's the chance of being left-handed. We need it to do part C. If for some reason you were not able to get that number, and you're looking at part C and you're saying to yourself, I know how to do this, but I don't have a number, what you can do is in part A, just say, assume that it's, and pick a number, 10%, 12%, doesn't matter. You are allowed to take your wrong answer from here and use it in part C and get full credit. So that's the thing you can do. Okay, but I'm gonna need to grab this number to get started. So the chance of being left-handed is 11385. No, that's probably too many decimals. 5 significant figures is a bit much, given that we started out with 2 significant figures. So I'm gonna call it 114. So that's what we're starting with to do C. So let's take a moment and figure out why this is a binomial probability problem. In the notes for the first assignment for binomial, it said, what is an error that students make the most? The biggest error with binomial problems is students don't notice it's a good time for binomial. So people try to do it different ways that are much longer instead of using the binomial probabilities. So just a heads up, that's very common, even with multiple choice questions. Just not notice it's time for binomial. So I'm going to give you lots of practice with that next week. All right, heads up, if you look at the formula sheet, it's the first page. We have a whole section for binomial. It's right here. It gives you the formula, gives you the mean and the standard deviation, should you be asked about it. I don't think we need this part. This is where we're going to focus when we talk about that. Okay, so why is this binomial? Just sort of, how should you notice? So you have this criteria. It's spelled bins. So we're looking at something that's binary. So there's a success and a failure. So the success in this case is being left-handed, and the failure in this case is being right-handed. Sorry, guys. So we're defining success, and there's a yes or no option here. Independence. The idea with independence is each of these 20 people that's going to get selected will not affect other people's chance of being left-handed. So maybe we don't get a pair of twins in there. Okay, that's going to be interesting. So we're ignoring the fact that we know that what kind of birth year affects it. But each of the 20 people's left-handedness is not affecting anyone else. That's independence. N is a fixed number of attempts, number of trials. So we're doing 20. N is 20 trials. We are selecting 20 people and asking, are you left-handed? Right. And then the final one, often these two are kind of very critically linked. But the idea is that the chance of success is constant, so it doesn't drop, right? So the chance of success, the probability of success we defined as left-handed, is always going to be 0.114. So situations where this doesn't apply is like, let's say you're standing at a free throw line throwing basketball free throws. You do it for a really long time, you're gonna get tired and you're gonna be changing your success rate. So that would be a situation that does not apply. Okay, so this is just sort of a, hey, this is a binomial opportunity. Okay, next up. If you take lots and lots and lots and lots of samples of 20 people, the number of people who are left-handed in those samples will vary, right? So sometimes you'll have 0 people who are left-handed. Sometimes you'll have 1 person who's left-handed. Sometimes you'll have 2. Very rarely you'll have 3. Everything above 3 is kind of super, super low. Like 20 out of 20, probably not happening. Okay. So, but there is a distribution out there for this situation And this situation is one where, okay, you know what? Let's notate this, right? So the notation for this is binomial trial number of trials probability. So that's the notation, kind of like we do normal curves. So we would say this is binomial with 20 trials and a probability of success of 114. Now, if we look at this entire distribution, everything that could possibly happen when you do 20 trials, the number of successes could be anywhere between 0 and 20. Much more likely to be on this end, right? So you can calculate the chance of 0 people being left-handed out of 20. You can calculate the chance of 1 person being left-handed out of 20. So, and then this question is asking us about the chance of at least 3. So 3 or more. So we're going to ignore 0, 1, or 2. Actually, we're going to need them to do this. But okay, so let's talk about how to calculate this one at a time. So I'm focusing on doing 0, 1, and 2. So let's start with the probability of having 0 out of 20 folks being left-handed. So the way to do this is, for binomial, you need 3 components in your formula. So it's going to be number of ways to achieve what you want, the chance of success, and the chance of failure. The chance of having the number of successes you're interested in, the chance of failing, the number of times you need to fail. So that's the 3 components. Now, good news, if you're choosing 0 out of 20, there's only one way to do that. Nobody's left-handed. Every single person's right-handed. That's only one way. The chance of succeeding, having 0 people be left-handed, is you want this 1/4 probability to apply to nobody. Okay? And if you're succeeding 0 times and you're doing 20 trials, you actually need to fail 20 times. And we need to get the probability of failure here, and that's going to be 1 minus this, right? You're either left-handed or you're not. So let's go ahead and say probability of being right-handed is the complement of being left-handed. Complements can be written a variety of ways. You can put a C or a prime, or there's a couple different ways to do that, which is 1 minus 0.114. So 0.886. Okay, so that's this probability. So I can do that by hand. It's really not that bad. That's a 1, that's a 1, because it's the power of 0. I just do that. So if you ever are doing this one's super easy. So the power of 20. By the way, you can do this problem much faster than this. I just want to talk to you about binomial stuff. Okay. So next up, probability of having 1 person left-handed out of 20. There are a variety of ways to do this. First person could be left-handed, second person could be left-handed, third person could be left-handed. So basically, if you list out your 20 people, it doesn't matter which one is left-handed. So there are 20 ways to achieve this. Okay. Next up. Alexa, stop. Okay. 1 person's left-handed. I need to succeed once. Okay. There are 19 more people in my sample. All of them absolutely should not be left-handed. So I need 19 failures. Okay, so this one, again, could do by hand. If you want, it's a little tedious. The other option is to use our fancy button. Fancy button's super important here. So this is what I write down on my paper to get credit. What I'm doing on the calculator, I'm going to write down for you so you can follow, but it's not worth anything written on paper. So go to distribution. Looking for binomial. It's towards the bottom. We're looking for PDF, the chance of 1 particular success, so 1 success. So 20 trials, chance of success 114. I'm interested in 1 success. So what it's going to do is literally do this for me. Okay. All right, so this one's pretty high chance. And the other reason I wanted to show you this is I wanted to kind of start building this idea, this graph up here. So we have, this is a really high one. Okay. 8% chance of having 0 people be left-handed. So this is a bar graph, a histogram. 8% chance for 0. For 1, 23% chance. Okay. So, chance of having 2. Again, super, just want to talk to you about how to do this. Want to show you calculator stuff. This is not how I would do an FRQ in like 12 minutes, but so this one gets a little more complicated. If you have 2 people that are left-handed out of your 20, it could be person 1 and 2. Stick with person 1, it could be person 1 and 3, person 1 and 4, person 1 and 5. There's so many ways to do this. When you're done with keeping person 1, you're like, okay, person 1 is right-handed. Now person 2 and 3 are left-handed. Person 2 and 4 are left-handed. You're trying to get all these combos. You want to know how many different ways can I achieve this? The reason you need that is this probability that you're doing here without the front number is a chance of having that particular combo. So first person, second person. And then you need, and the probability is the same, but there's so many ways to do it, you have to add them all up. So you're multiplying by how many ways there are. Really important, a lot of people forget this part. So for this one, we're going to use the formula. This is the chance of having 2 successes. We're doing n choose 2. Okay, so we're doing 20 choose 2. 2 people are left-handed, and they succeed at being left-handed, and then we need 18 people to not be left-handed. These guys have to add up to 20. So these 2 add up to whatever the first number is at the top. Okay, so this one is actually really painful to do by hand on the calculator, so don't recommend doing it. Write this down so that you're explaining yourself. Then you're doing the binomial PDF button again, so stat, distribution, second bars. I scroll up to get to the bottom section, and I can find my binomial PDF. Now this time, I just want 2 successes, slightly different. Okay, so pretty high chance. Going back to my graph, I was worried about this. I wasn't sure how big it was. Oops. Okay, so this is super skewed right distribution. And now I have the numbers I really need to get this done. So here's the deal, guys. Question's asking. So heads up, this is just explaining how this works. Now we're answering the actual question. So what's the chance of having at least 3 children who are left-handed? So that means 3 through 20. Right, so whatever the rest of this graph is, that's what the question's about. Now I'm not going to do all of these, and your calculator is not capable of doing more than. I'm not good at that. So let's kind of roll this out. I'm saying this is binomial 20, 1, 1, 4. This question saying, what is the probability of having at least 3 left-handed kids? At least includes your 3, right? So I'm going to rewrite that. I'm going to say, what's the chance that x is more than or equal to 3? Okay. The way we're going to solve this is we're going to answer this as 1 minus the chance of having x be less than or equal to 2. Right? So if I have 0, 1, and 2, that is what I need to know so that I can tell you what's left. So the way you can do this on a piece of paper to explain that you know what's up is you show this notation. You say, hey, I am doing 20 choose 0, 0.1140, 0.88620, and 20 choose 1, 0.1141, 0.88619, and 20 choose 2, 0.1142, 0.88618. These are the ones I don't want. Everything else qualifies for this event, right? Calculator can do less than for you. You can't do more than. And heads up, guys, you have to be super clear. Which number do you want to include in your answer? Which number do you want to subtract out? So be very, very careful, right? Make sure that these don't overlap. Make sure you're not missing a number. Just gotta make sure you're really clear in your mind what's up with this. So now that I've written this down, calculator pressing time. So I'm going to say 1 minus binomial CDF. That's a shader. 20, 1, 4, 2. So I'm saying please remove everything that is 2, 0, or 1 from my final answer. So this was PDF to get this one, to get a particular value. So this is x is equal to 2. This is a less than or equal to what we're about to do. So distribution, scroll up, this one. Looks the same. Super dangerous. Be very, very careful that you notice which one you're doing. So 20 trials, 0.114 is our success rate. 2. So we would like to know where we'd like to shade up to 2. So 0, 1, and 2. Okay. So this is saying that 0, 1, and 2 add up to 0.5970. Yeah, I can see that. Right? 27, 22, it's 49 plus 9. Yeah, okay. So, and then I have to subtract that. And what's left is 40% of people. So we're going to say 40% chance that a sample of 20 people has 3 or more left folks. That's what we found out. So we found out the rest of this graph, which is going to start dropping, making a really long tail. Didn't want to do it one by one. The calculator won't do a more than for you. We subtracted the part we did not want. Right, so these guys were no-nos. Got rid of them by doing 1 minus those 3.